Hi, everybody, and thank you for joining. Today, we will be talking about the PR complexity score. We will be sharing how we reduced it, and hopefully you can do too. And all of this with a little bit of help from AI. I'm Caterina. In my previous job, I've been a software engineer consultant, and I've been traveling all around the world as part of that job, which was pretty cool. But that's my past. I joined Atlassian in 2015, so it's been almost 9 years. And my job has always been centered around developer tools, both internal and external. Right now, in my current role, I'm a developer advocate, and I collaborate with our developer platform team on multiple projects. So I can probably say that I'm involved on a daily basis on conversations about developer productivity.
Thanks. So, hi, I'm Chris, and I've been working at Atlassian for almost 5 years now. I've been working on a number of developer-focused teams, like developer platform teams, from the public API for escrow.com to the platform modules for our self-hosted products to now the platform that powers our app ecosystem for our cloud products known as Forge. I've worked across all sorts of tech stacks, from .NET to Python Flask, Node, React, TypeScript, Java, and more. And no matter what tech stack we've been working on, what I've found is that setting yourself up for success with a productive environment and a key set of practices is very important to achieving the best outcomes. So let's start off with a bold statement. Complex pull requests murder productivity. Let me repeat that twice. Complex pull requests, they murder productivity. If you're not taking them seriously, hopefully I'll convince you a little bit of why they should be top of mind for productivity-minded engineers such as yourselves. Today in our talk, we want to explore this and show you how we helped Atlassian developers reduce their pull request complexity and to increase their productivity. The industry consensus is that small pull requests are better. We'll get into the definition of complexity a bit later, but first let's have a look at the engineering practices that Google have shared, written by Max Alexander, who's also at this conference. So thanks a lot to him for writing up this. So what we've got is we've got 4 key points that we've extracted from his thing, but have a look at the URL if you want to go through more of his good points. Small pull requests are reviewed more quickly. It's much easier to find 5 minutes than several times a day than 30 minutes in a block. It's more easily to thoroughly review it. No more looks good to me, green tick. You can much more easily spot issues in the small pull request. And following on from that, it's easier to spot bugs for the same reason. More importantly, or just as importantly, I guess, there's less wasted work if the reviewer disagrees with the direction. You haven't wasted your time. If they get rejected, you could start again because you haven't done that much work. So what is a small pull request? Well, it addresses just one thing, just like this slide. The definition of a large size change is intentionally vague. By Max, this is from 100 lines of code is small, 1,000 is large, but it's up to your judgment. Number of files matters too. It mostly comes down to addressing just one thing. If you can break the scope down further, address that smaller scope thing too. The true impact of how this impacts productivity is hard to grasp for some, easy for others, very obvious for many, I would say. So let's go through a couple of diagrams I've created to share internally with the junior engineers on why this is such a big deal. So I wrote up this diagram to be intentionally quite contrived, but I think you will find that this matches reality far more often than you would expect. Quite often, a developer will create a pull request. If they're doing their due diligence, we all skip it sometimes, we do some self-review, and this can take 20 minutes here and there if you've got a very large pull request. Then you get into the review stage, and this is where you really lose time. So you might spend 20 minutes reviewing a pull request, and then you lose context due to lunchtime, and then you could get back and you try to catch up, and you lose another 15 minutes until you get a request, and so on and so forth. Going back to this whole idea of finding 5-minute blocks versus 30-minute blocks. And moreover, it's much more likely that you're going to encounter an issue where the pull request gets rejected, or changes are requested and has to go through the cycle all over again. Small pull requests, ignore the line count here. This is just a general example, but they're way more straightforward. Self-review will take only a few minutes because you know what you've coded. Once you go into the review state, it takes 5 to 10 minutes to review. And then once you get to that stage, most of the time, since the developer has done their due diligence, it's much more easy to get accepted because usually the developer themselves will spot issues as well. But yeah, don't just take my word for it. We've also looked heavily at the data, and together with Simon Zhao, one of our amazing data scientists, we've taken a look at an entire year's worth of data within Atlassian. Like, not our Atlassian users, to be clear, like, you know, that's like, we've got privacy clauses for that. But within the company itself, we've looked at how we develop code, and we've found some interesting things. So I want you to learn from some of our learnings. So before we get into this, we talk heavily about the pull request complexity score, which is something that we've mentioned in the title of this speech. So there's 3 key elements that we've looked at for this case, and I want to be clear here that this is just what we've chosen, and we've found some very interesting things from. But you should not feel bad about adding your own metrics, just like in the keynote that we looked at and learned from. No model is perfect, so you want to make your own trade-offs. But to explain it, it includes the number of files changed in a pull request, the number of comments made in the pull request, which may be controversial because you can understand that the complexity will change over time, but we've found that internally, it's a very good signal of a complex pull request, because the more a pull request is discussed, the more likely it was too large in scope. And finally, we have a measurement called the significant lines of code. And this is lines of code that are stripped of certain things like white space, delimiters, comments, and so on, to try and be as agnostic to differences in stacks as possible. Obviously, like, there's still going to be some biases because everyone has different practices, but overall, we've found this to be quite useful. So each one of these has an equal weight. That's another important aspect of this, and they are all based on percentiles. Because of this, the score is from 0 to 1. And effectively, it's very easy to compare it, because you have an easy sort of measurement. That is to say, like, files and comments scaling out of control aren't going to just put the score to the maximum. So now let's have a look at some interesting statistics we've found. This one is probably the most obvious one, but it's good to have it confirmed here. So pull request cycle time is improved if you have less pull request complexity, or conversely, in terms of this chart, as the pull request complexity increases, you will see that the time from create to merge increases, and the orange line above also shows the time from creating a pull request to deploying it to production. So while there's a less steep correlation there, in both cases it is very helpful. And in the most simple cases, for the most simple pull requests, you can see it's less than 1 hour, which is quite good because within Atlassian, we have a remote working culture and people can be in a meeting or having lunch. So less than 1 hour on average is very good for the most simple pull requests, but it scales up to 100 hours or more for the most complex ones. So really, you're damaging your productivity if you're not making your pull requests simple. So next, let's have a look at the issue cycle time. Within Atlassian, issue cycle time is defined as the time from working on an issue to when it's deployed in production and the issue is closed. And you can see that there is quite a strong correlation between these things as well. If you've got metrics assigned associated with how quickly issues are closed, this is another reason to optimize the complexity of your pull requests. A subtle thing I want to call out here is that there's a few confounding factors that are at play here. So an issue can have multiple pull requests associated with it, and smaller pull requests will encourage this sort of behavior where you have more pull requests. And even with that, you can see that there's a positive effect, at least up until that 0.2 point. And it also kind of shows you here that once you go too small, there can be some other issues that come into play where you're putting too much extra work on yourself. The other thing that I want to talk about with relation to, I'll go back to this in a following slide, is going to be the scope of an issue. So we'll get back into that in a couple of slides. Another thing which I think a lot of the people at this conference will find very interesting is the build failure rate. In our experience, it's one of the most insightful measures of pull request quality and confidence. And the failure rate of the first build after merging after the main branch, you can see that there is a correlation here to pull request complexity. In the end, we know that a failed build means that the pull request reviewers, they approved it, but it still didn't succeed as expected. And this lowers the confidence level of the team. It also has ongoing effects on the rest of the team's productivity because now the team has to address the failing build. And it can really block all sorts of team members. Operations, too, can be blocked from putting out fixes to incidents and all of those things that you can imagine are associated with build failures. So looking at the data, we can see that the build failure rate of the analyzed data starts at 12% and increases quite rapidly to almost double like the original value, and in some cases even more. Because build failure rate is probably an important topic for many of the people here, I wanted to share the results of another investigation done by our data scientist. You can see that the PR complexity increases the build failure rate, but as a reminder, it only includes the lines of code, the number of files, and the number of comments. But we're always looking for opportunities to expand it further, and we could include things such as the number of configuration files added and the number of test files added, and these things also have a correlation to the amount of build failures that occur. Another interesting factor is the number of reviewers that are assigned to a pull request. Often this is an indication of unclear ownership of source code. And this is something that's been given a lot of focus in recent years in many organizations. There was even a talk in this room about this too from LinkedIn. And the attempt to find the right owner can be something that also affects these build failure rates. So at the end of the day, source code ownership is complicated, but it's something that you should be trying to fix from this perspective as well. So I'm almost done with the charts. I promise there's only a couple more. Here we're actually looking at the inverse relationship. So what actually drives the pull request complexity? And this one is quite interesting. So you wouldn't expect it, but I want to explain these two different metrics. So firstly, in the orange, we've got the average word length. And average word length includes things like URLs and links in the issue. So once I mentioned that, this might make a bit more sense. And you can see that when the average word length is longer, you end up with less pull request complexity. So this could be due to one of two things. One of them is that you have a higher ratio of links to the description, meaning that there's plenty of context given. But it could also mean that the description itself is lower, and many people will put links in anyway, meaning that the scope of the issue is also smaller. So this is something that you should keep in mind when measuring metrics for issue descriptions. On a similar note, the character length of the issue description has the opposite effect. And as you might imagine with that, that's possibly because that the issue is too large in scope, generating longer pull requests, because many developers assign one pull request to a particular issue. I don't believe that's a practice you should follow, but in practice, it's very easy to go in that direction. So why make it hard for developers to make simple pull requests? Keep your issues simple. This is another very interesting one that I wanted to talk about. So the number of issue watchers and comments. You might have expected that more comments and issue watchers would have increased the pull request complexity, but we've found the opposite here. One explanation is that issues with more comments and attention are more likely to be assigned to senior engineers, whereas another one you could think about is the fact that more comments on an issue means that it has been refined more carefully and scoped down. If you have any other theories about this data, let me know after this. I'm curious to hear if you've got your own thoughts. So to recap, we can see that the consequences of pull request complexity are threefold. You have longer review cycles, you have issue cycle times that are longer, and higher build failure rates. And just to recap, the pull request complexity score is a combination of these three things: the number of files in a PR, the number of comments, and the number of significant lines of code. For simplicity, we've assigned equal weights, and each value is a percentile representation. And for those using Jira or similar, we've found these two metrics to be important for driving the pull request complexity itself: the size of the issue description and the issue watchers and comments. Obviously, there's the parts of the score itself that we've mentioned, but these are things that you may not have thought of. So now I'll hand it over to Caterina, who will explain how we've leveraged our developer platform capabilities to improve this.
So now that we know more about the concept of the complexity score and how it can impact the cycle time, we want to show you how we help the developers reduce the complexity of their PRs. And the good news is that if you are a Bitbucket user, you can take advantage of the solution that we built and help your teams in the same way. So how did we do it? With a Forge app. So what you see on the screen right now is a screenshot of the app we built. And this app shows the information about the complexity score of the pull request directly in the context of the PR. And it also has some other cool features that I'm going to share with you in just a moment. But first, you might be wondering what is Forge, as I know by talking to many developers as part of my job that many of you are still not familiar with it. So Forge enables developers, just like you, to extend the Atlassian products by adding UI elements on top of Jira, Confluence, and Bitbucket. And it also provides some advanced automation and customization features. And we will see that in a moment as it's part of our solution for PR complexity. Forge runs on the Atlassian cloud, so you don't need to host it. And to preempt the question that I'm asked the most often, it's free, so it's included in the product, in every cloud plan. So if you're using cloud, it's available at no cost to you. Forge can do much more than what we'll see today, and it can really help to optimize and customize your workflows, which I believe is probably top of mind for this audience. So keep Forge in mind if you're thinking about a specific use case that you have maybe in your team or maybe in your entire company. So the complexity score is really just one of the aspects of this app that our internal platform engineering team built and made available for everybody at Atlassian. So the goal of this team is to improve the developer experience of the Atlassian internal developers. And while they were looking for the most critical opportunities, they realized that each team has a set of best practices, but these best practices are maybe in a document, on a Confluence page somewhere, and they are hard and so it's hard for the team members to locate them when they need it. So what they did to solve for this was to bring the team's best practices directly in the context of a pull request by extending its UI using Forge. And this is one of the examples of what I meant with customizing or extending Bitbucket. So if you log in to your workspace, you will not see this. This is an app that can be added on top of Bitbucket. And I'll also share the repository at the end if you want to check out how it works or maybe give it a try. And the other thing I want to explain is why extensibility. So I believe this app really shows the value of extensibility, meaning that while most of the best practices are common to all teams, we noticed that each team might have some specific ones, and we wanted to leave the freedom to each team to only show the ones that are really important and that they really matter about. And an app makes all of this possible as the logic is very flexible and is also in control of the individual teams. And so Chris and I, we've spent a lot of time on this app and talking about this app. So I could be talking about this for a very long time, but that's not the reason why you are here today. So I will not do that. But I want to share one best practice that is part of this app and I always get questions about. So I want to share it with you. And we were actually chatting with somebody like right before this. And that's the usage of comment prefixes. So and this is not playing. Oh, now it's playing. So what is this best practice? Is it playing?
Yeah, it's ready.
Okay. So I wanted to show that to you with an example. So, you know, when you are going through the feedback of a PR and there are a lot of comments, but it's not always clear what the reviewer is expecting from you. So do they want you to take action on every single feedback they provided? Are they maybe just asking a question or maybe providing an information as a learning opportunity for maybe a less experienced team member? So the idea here is to use prefixes, which we just show for each feedback. And these are taken from the comments of your PR. So in this case, we are using the neat one and the best practice. So next to the best practice, we had a green tick. Which was an indication that all the comments in this best practice are matching the expected format. So, yeah. So in the same way as the comment prefixes, we are also showing the PR complexity, and it's part of the same app. So this is done by adding an additional UI element to the same app and to the pull request UI. So the complexity level, whether low, medium, or high, is immediately visible to both the author and the reviewers. So it eliminates any need for, mental calculation, people having to think about it. And this information is ideally used by the author of a PR before submitting it, but can also be used by the reviewer to pay attention to certain aspects of as part of the review process. And furthermore, the reason behind the complexity score and its value can be further explained by opening the Learn More dialogue, where all the individual criteria and their values are presented with some suggestions on how to reduce the score. The values that we are showing are all calculated by the app based on the change set and the comments of the PR that is currently open on the screen. So in this dialogue, you can see the contribution of each criteria to the score, and this can help to further understand how to simplify it. And so, for example, we see that in this PR, the most contributing factor is the high number of modified file, which is highlighted with that red losange. So we had the data, and that was thanks to the work of our data scientist, Simon. So that was all available to us. But what if you want to present the data in a different way? Or maybe you want to redo the analysis on your own data, or maybe you want to add or remove some of the criteria. So that's why I'm showing a snippet of the code of this app, and you're more than welcome to use it as is, using the criteria that we are using. Or if you want to perform your own analysis, you have the option to send the data directly from the same app to an external data system, or you could even store some of the metrics and trends directly in Bitbucket, and you can show them in a table or maybe create some charts, always using the same app. And maybe if you identify some other criteria that you want to use because they are relevant for your team, you can add them to the score too by using the multiple available APIs, which allow you to retrieve information from a pull request and its change set. So, showing the information about the PR complexity in the same UI where authors are creating and submitting the PR and reviewers are providing feedback is something that our internal development teams are telling us that is already of great help. But in our app, we wanted to go one step further, and we added a PR complexity score check. So this is a custom merge check, and custom in this context simply means that it's on top of what is available in the product and can be coded and added by any developer for their specific needs. So this custom merge check has proven its value to highlight the complexity of a PR before somebody pushes the merge button. And this is because it is presented right before submitting, triggering the merge. So while this merge check could be set up to stop a merge from happening, most of our teams only set it up as a recommended check, which means that the merge can still proceed even if the PR is classified as being complex. So you might be wondering why we are doing this. And the reality is that this is done on purpose, and is something that we've been doing with other custom merge checks too. And that's because showing the complexity is great for just getting the developers used to the concept without disrupting their workflows, which we don't want to do. But we've also seen that just with this information, over usually like a few months, teams will change their behavior and start reducing the complexity of their PRs. And when that happens, we then suggest to change that to stop the merge from happening if the PR complexity is above a certain threshold. So, what about AI and how did we use it? So what we did in our app was to ask AI to help the author and the reviewers by doing an initial review and highlight any possible improvements with a special focus on its complexity by using a very specific prompt. So we do that by invoking the OpenAI REST APIs from our app and providing the context of the pull request. So after a few attempts and a couple of failures too, we concluded that the best option was to ask AI for two things. So the first one is a review on each file, which results in what we call a code insight, and it's available on this side of the screen. So, and this feedback is not strictly and not always related to the PR complexity, but we still found it valuable. So we decided to provide that. And then we also ask AI to review the PR and all its changes as a whole with a focus on its complexity. So, and we then take the results and add them as a comment to the PR, which you see on the top right of the screen. And so this comment is added as soon as the PR is created and every time it is updated. And it helps with the more precise instructions, which can be very specific, so as specific as needed. There are many more ways to use AI in a Forge app. So I've seen customers using it to summarize pipeline results because the output of a pipeline can be pretty long and detecting errors can be tricky, while AI can help surfacing the issues with a pipeline way faster than an individual can. And another example that I want to share with you, and I've seen customers using, is to use AI to provide an overview of all the changes that occurred in a repository directly in the repository homepage. And this could be presented as the summary of new features, refactoring, and maybe bug fixes, and can be shown to everybody who's having a look at the repository to understand what changed, for example, in the past 30 days. So to wrap it up, today we presented our definition of the PR complexity score. We showed you how it contributes to a PR cycle time and even to the release time. And we presented how, with the help of an app, we aim to reduce it by bringing the relevant information to the developers directly where they work. We understand that there is no magic wand for this, but we've heard very positive feedback from our engineers, and we are happy that our efforts are paying off. So the QR code that you see here on the screen, which will lead you to the same Go link there, and will take you to a short page containing the resources that we shared, including the Google engineering practices that Chris talked about, the source code of our app, and an article about the common prefixes best practice. And so go and check it out if you want to know more. And I think we have some time for questions now.